Welcome to H1. Okay, students, today we shall be learning some more concept regarding lines and angles. Here we shall be learning when two lines are given to us parallel. Okay, we shall be learning, suppose if two lines are given to us parallel, two lines are given parallel. Okay, parallel and one transversal. And one transversal intersect these two lines. Intersect the two parallel lines. Then we are having some more properties. So let us learn that one. Okay. So what is this? So now let us say, suppose two lines are given to us parallel in the question. Okay. If two lines are given, suppose, now let us see. For example, if say suppose AB line is parallel to CD. Okay. This is the symbol for parallel lines. Okay. This parallel. So for example, suppose two lines, AB is one line and CD is one line. For example, let me draw here, suppose AB, this line A, B, and CD. CD is also somewhere else one line here, CD. Suppose these two lines are parallel lines. So what is the meaning of parallel lines? Parallel line means the distance between this A and C and B and D will be same. Even if we extend more and more, okay, this distance will be always same. These two lines will never come and intersect each other. They will never come and cut each other like this. They will never come. Okay, they will never cut each other. So they will always go parallel only. So that type of lines are called parallel lines. Okay, I think what is parallel lines is clear for you. And now let us see, if these two parallel lines, okay, is intersected by one transversal, one more line. Okay, that means another line is intersecting these two. That means you can say, suppose EF. Okay, line EF is intersecting to these two parallel lines AB and CD, cutting to AB at, say suppose Z, and cutting to CD at H. Okay, at point H. Then they are having some more relationship here, we can see. So we have already learned, if you see only one line, then we have already learned the vertical opposite angles are equal. It's not it. And that sum of adjacent angle is equal to linear pair. It's not it. 180 degree. All these things we have learned already in our previous classes. But now we will learn, if two lines are given to us parallel and if one transversal is cutting that, intersecting to these two parallel lines, then what are the equal angles? Let us see now here. So here what we are having, firstly, if AB is parallel to CD and, let me write it clearly here, and EF intersect, suppose EF, it intersect AB and CD at G and H. Okay, if it is given to us like this, then what are our properties we are going to have here? So which angles will be equal and which angles will not be equal? So we know already. Number one, let us see here. So when two lines are parallel, so we can say always their alternate angles are equal. So what is alternate angle? So this angle and this angle is alternate, and this is inside between these two parallel lines. So that's why this is called what? Alternate interior, inside. Okay, alternate interior angle. Okay, So now let us see here. We can write that number one. What we are having? Alternate interior angles. And you have to know always alternate interior angles are always equal to each other. Okay, alternate interior angles are always equal to each other. That means what I can write here, this angle and this angle is alternate. Also we know this angle and this angle is also alternate. That means this angle is also equal to this angle. So both are inside. So we can say these angles have an alternate interior angle. So what we can say, angle AGH. Alright, AGH is equal to angle what, DHG. This angle DHG, because these two are alternate interior angles. Also what we can see here, that this angle is also alternate angle to this angle, so these two angles also are equal, we can say. So angle BGH, angle BGH is also equal to angle BGH is also equal to this angle. This angle is equal to this, that means CHG. CHG. Okay, so these two are our alternate interior angle, they're inside. Okay, and we can find here also outside also. So now we can see outside also, that means this angle and this angle, these are outside or not, and they're also alternate, but they're outside the parallel line. So what we can say, this is also alternate, but this is not alternate interior, this is alternate exterior, outside. Okay, and they will also be equal to each other. So number two, what we are having here, alternate exterior angles. So exterior angle, alternate exterior angles are also always equal. Okay, alternate exterior angles is also always equal, so we have to know. So this and this is alternate exterior angle. So let us write AGE, angle AGE is equal to angle DHF, angle DHF. So these two angles will be always equal because these two angles are alternate exterior angle. Okay, and we know this angle also is alternate angle to this angle and this angle. Alright, that means these two also will be alternate exterior angle. That means these two angles also will be equal. That means what I can write, EGB or BGE. This is same thing. Okay, so EGB, angle EGB is also equal to angle, this angle is equal to this angle. Then what we can say, CHF, because they are also alternate exterior angles. So you'll have to remember this thing. So if they're alternate angles also, they're equal to each other. If they're alternate interior angle also, they're equal to each other. So we'll have to know this. Okay, but when we are having alternate angles, only if two lines are parallel given to us and one transversal is intersecting both the lines, both the parallel lines, then only we will have alternate angles. Otherwise there will be no alternate angles. So we'll have to remember that. Okay, if the question is given, if in the question it is given that two lines are parallel, then only we can use, oh, this angle is equal to this, because these two lines are parallel to each other, so the alternate angles are equal, then only we can use this. Otherwise we cannot say that these two are alternate. If in our question AB is parallel to CD is not given to us, then we cannot use these alternate angles are equal, because the question had not given us that these two lines are what, parallel lines. So we need to be very careful in that thing. So again let us say now, so we are going to have here corresponding angles also. So what is corresponding angles? Number 3. Corresponding angles. So corresponding angles are also always equal. So we will have to remember this also. Like suppose if these two lines are given to you parallel lines, okay, and if one transversal is given to you like this, then which angles are called corresponding angles? Now let us see. And we know corresponding angles are always equal according to the property, okay. So now which angles are called corresponding angles? So one is exterior angle, this one, okay, this angle and this angle. If you take one interior angle, you'll have to remember this angle and this angle. You cannot take this angle and this angle, because if you take this will become linear pair only, okay, because if you take only this and this, it will become linear pair, this and this. So you cannot. So corresponding angle means this angle and this angle. So if you take these two angles, then these two angles are known as corresponding angles, and we should know that these two angles are always equal to each other. The properties of corresponding angle is giving guarantee, okay. So let us write it down. Then here how many we can say? This angle is equal to this angle, because these two angles are corresponding angles also. So what we can write here? Angle AGE, this angle, alright, angle AGE is equal to angle, this angle, so this angle and this angle. So what we can say? CHG, this angle, it's not it, CHG. And also what I can say? This angle, alright, this angle is also corresponding angle to this angle. So we can write this angle and this angles are equal. That means EGB, angle EGB is also equal to angle, this angle now. That means DHG, DHG, alright, DHG, this angle. So also what we can say then? Again, this angle and this angle also will be corresponding angle then, alright. This angle and this angle is also corresponding angle, because this angle and this angle is also corresponding. We can say this angle and this angle is also corresponding angles, and we can say what? This angle and this angle is also corresponding angles, alright. So let us write it down again. Then what we have got here again? Angle, what we can say now? CHF, this angle, okay, CHF also, right? Angle CHF is equal to CHF, this angle is equal to this angle, AGH, angle AGH. So also let me write this now. Also what I can say now, this angle is also equal to this angle, because these two angles are also corresponding angles. Then what we can say? DHF, angle DHF is also equal to angle, DHF is equal to BGH, this angle and this angle. So BGH, BGH, alright. And then again we can say this angle and this angle also we have got already. So this angle and this angle, this angle and this angle, so this angle and this angle, this angle and this angle. So all these are what? Equal to each other because of corresponding angles, okay, because they are corresponding angles. So if two lines are parallel given to us, we should know these things. This property will come in that diagram, okay. In that question we can use these properties to find out our angles. If this angle is not given to us, then if this angle is given, then we can directly say this angle is equal to this angle, because corresponding angle is giving us guarantee that these two angles are equal to each other, okay. So we can use this property. So you'll have to remember, if two lines are parallel given to us and one transversal is intersecting to these two lines, okay, then what happens? We'll have to understand, oh, the alternate angles will be equal, okay. Alternate exterior angle also will be equal, alternate interior and exterior angles will be equal, as well as corresponding angles also will be equal. So you will have to understand this, you'll have to remember this, and we can solve our coefficients if two lines are given to us parallel and one transversal is intersecting. So we can find out any angles if we remember this property. So okay, let us learn one more property. If a triangle is given to us and if one side of triangle is produced, okay, produced to a point, then there is also a relationship. So let us try to understand that one now. So let us see, for example, if one triangle is given to you, let's suppose A, B, C, okay. If this is a triangle A, B, C, is any triangle it might be, okay. A, B, C is given to you, and if, suppose for example, let me tell you BC, if BC is produced to up to D, okay, then here what we can get, you see here, we can get here one angle which is outside triangle, am I right? So we can get one angle which is outside triangle. So then what we'll have to know here, one property is form. So what is that property? Let us see. That property is telling us that this angle, okay, the exterior angle, the angle which is formed outside the triangle, is equal to the sum of the two interior opposite angles. See, okay, that means this angle will be equal to sum of this angle plus this angle, then this angle and this angle, okay, not this angle and this angle, it will be this angle and this angle only. So for example, how we will write this now? That means angle DCA or ACD, you can write anyone, let me write ACD, this angle, okay, ACD, this will become equal to this angle plus this angle, then you can say what? ABC, this angle, am I right? Angle ABC plus angle, this angle, BAC. So this is one property, so you'll have to remember. So this property is called exterior angle is equal to sum of two opposite interior angle of a triangle, okay. That means what we say, exterior angle is equal to sum of two interior sum of two opposites, sum of two opposite interior angles of a triangle, okay. So you'll have to remember this is the name of this property. So exterior angle is equal to sum of two opposite interior angle of a triangle. So let me explain it in a different way. For example, now let us see again. Instead of extending this side, now if I will extend other side, so for example CB is produced to say here D, then what happens? Then we know here one angle is formed, then this angle will become equal to this angle plus this angle. So you'll have to write very nicely. Then what it will become here for this question, you can see here, that means angle DBA, okay, DBA will become equal to this angle plus this angle, okay, angle BAC, this angle BAC plus angle or ACB. So which property? This is the property. So now you see here, I think you have understood property. So we can use it in this way, this property. So you'll have to remember this one, okay, so that we can solve exercise 6.2 very clearly and very nicely. So okay, let us solve now question number 1 of exercise 6.2 class 9. Okay, so here it is given to us like this. You see in the question, in figure find the value of x and y. That means our figure, okay, this diagram is given to us, and in this diagram you'll have to find the value of x and y. That means our x value and y value is how many, you'll have to find it out, okay. and then show that AB is parallel to CD. Then after finding the value of x and y, that means you'll have to show that this line AB and CD are what? Parallel lines. So here what the question is saying us is that in this diagram some missing value like x and y, okay, is given. You have to find the value of this missing number x and y, and you have to show that this AB and CD are parallel lines. So now here, so don't be confused that oh, we have to prove that this is AB and CD are what? Parallel lines. So then don't think that these two lines are given to us parallel line. It is not given to us parallel line. So it is not given to us AB is parallel to CD here. So we have to prove only. We have to show that these two lines are parallel. So here we cannot use any corresponding angles are equal, any alternate angles are equal or not. But we can do one thing here. If we can prove this angle x and angle y is equal, both are equal, then we know if two lines are parallel to each other, we always know their alternate angles are always equal. If it is parallel, if these two lines AB and CD are parallel given to us, then we can say this line and this line is equal. So here it is not given parallel to us, AB and CD lines are not parallel, but we will try to find out x and this y. Okay, this x and y, if these two angles are equal in measurement, if we can get x value same as y value, then we can say oh, then these two angles are also alternate angles. They're in the place of alternate angles. Then we can say AB is parallel to CD. This is the point what we'll have to prove now here. So okay, let us prove here. So now let's see here solution. Here let us find out first x. Okay, we cannot say this and this is equal because these two lines are not parallel now. So we have to prove one. So let us see here. Then let us see only this one. Okay, let us not see this. Then let's see this angle plus this angle. We will get one straight line. Am I right? See, 50 degree plus angle x. If I do, I will get one straight line, and we know this is one linear pair property, 180 degree. So we can use this. So let us use this property and find angle x. Okay, and when we look here also 130 degree and y, if two lines are intersecting each other, we know vertically opposite angles are equal. Am I right? Then y also will be equal to 130 degree. So after that we will compare our x and y are equal or not. If they are equal, then we can say oh, they are lying in the alternate place. So we can say this line and this line are parallel to each other. Okay, so let us do. So now let us say this angle plus this angle is equal to one straight line. So let us use the linear pair property, which is 180 degrees. So let us write it. So here 50 degree plus angle x, or we can write directly 50 degree plus x is equal to 180 degree. So this is linear pair property. We are having one straight line. Linear pair angles. Okay, this is linear pair angles property. So now let us solve. Take out the value of x from here. So plus 50 degree will transfer to the right hand side. Then here remains only x is equal to 180 degree. So plus 50 degree coming to the right hand side, it will become minus 50 degree. Okay, then here our x is equal to how many now? So we'll have 180 minus 50 is 130 degree. Then we have what? The value of x is how many degree? 130 degree here. Am I right? Again, now let us find out the value of y now. So now let's see the value of y. So when we look only these two lines now, okay, so what we get? We know if two lines are intersecting each other, then their vertically opposite angles are always equal. So vertical angle property is giving us this guarantee. So let us write, that means angle y will be also will be equal to 130 degree here. So according to vertically opposite angles. So now again, then what I can see here, y is also equal to 130 degree I can say. So who is giving guarantee, which property? Vertically opposite angle. vertically opposite angles. Okay, vertically opposite angles property is giving us guarantee that angle y will be equal to 130, because we are looking here, two lines are intersecting each other here, then they are vertically opposite angles. Am I right? So now we have got what here. Now see, value of x is also equal to 130 degree and value of y is also equal to 130 degree we have got. So this is also equal to 130 degrees. See, both are 130, 130. And when we look very carefully, that means this transversal is cutting line AB and CD in 2 points, not it? And the alternate angles, when we are looking, finding out and checking, we found that these two angles are equal. That means these two angles are alternate angle also. X and Y, of course, they're alternate also, and we have found that these two are equal also. So therefore now we can say that, oh, the alternate angles are equal also. That's why we can say AB line will be parallel to CD. So we need to explain here very clearly. Okay, so let us explain. So now since what we have got, X and Y are both equal to 130 degree. It's not it? And also they are alternate to each other. Am I right? And also they are alternate to each other. Okay, they alternate to each other. So therefore what I can say, so therefore we can say that AB is parallel to CD. So now they are alternate to each other, therefore what I can say, they are equal also. So I can say this line AB is parallel to line CD. So this is how we'll have to show that how two lines are parallel to each other. Okay.